Everyone. Welcome to the second ever Science on Google Plus conversation. Today we are joined by Dr. Joe of It's Okay to Be Smart. I hope you checked out his blog. You've certainly seen some amazing posts that we sourced from itsokaytobesmart.com. So we're here to just talk about awesome science, answer some cool, fun, serious, genius, wacky questions, and just learn a little bit about Joe and what makes him tick and why he's so awesome. So we'll sort of start by introducing everyone here. So I'm Amy Robinson. I'm coming to you live from MIT's Department of Brain and Cognitive Sciences here in Cambridge, Massachusetts. I'm one of the moderators of Science on Google+, and I am the creative director of iWire, which is a game to map the brain from Sebastian Sung's Neuroscience Lab here at MIT. And I'll let everyone else here introduce themselves.
Hi, my name's Jason Davison. I'm a researcher at the University of Waterloo. I'm working on my PhD in earth science, and I look at coupled systems of how water and energy move through the environment. I'm a third-year PhD student, and I'm really excited to start this thing up.
I'm Nick Hammond. I'm in the Center for Excellence in Teaching and Learning at the University of Rochester in Rochester, New York. My PhD's in chemistry, and I did bench work and PhD in biophysical chemistry, looking at structures of nucleic acids in 3 dimensions. But now I'm into making teaching science better. So that's me.
My name is Benjamin Ballou. I work at Dendreon as a lead trainer. We do active cellular immunotherapy, essentially making a prostate cancer vaccine using the body's own immune system to help fight cancer.
That's awesome. And so last and really most importantly, we've got Joe Hansen here. So Joe, you want to just do a short introduction of yourself?
Sure. My name's Joe Hansen. I am a recent PhD in biology, but I don't let that limit me. I'm interested in everything. I'm now a professional internet science guy. I write itsokaytobesmart.com, and I also have a YouTube show for PBS Digital Studios of the same name. Really excited to talk with you guys today.
Yeah. So, Joe, your sort of tagline on your site is there's a lot of amazing science out there. Let's go discover it together. And for anyone who's kind of looked at It's Okay to Be Smart, if you go to a random post or if you go through the archives like I like to do, you'll find that there's every subject that you can possibly imagine and then some on your blog. And what it makes me think of is how, there's so much amazingness happening in the world, especially in the world of science. And you could really read 24/7 and not even begin to absorb it. So I kind of wanted to just back up and ask, where do you get your inspiration? You seem so zesty about life and learning and sharing all these awesome things that are happening in the world. Where does that come from?
Well, I mean, it's sort of like that kid's attitude where everywhere you learn there is something new and exciting. And as any professional scientist knows, you can't even hope to keep up with your own field these days. Like, it is just literally overwhelming the amount of science that comes out every day. And I am lucky that I get to do this sort of as a job, that I get to ask questions every day and try to answer them, and then get to share that with people. I feel like a teacher. I feel like, I'm discovering this stuff right along with people, and that's fun for me. I don't have to try. That's not a job at all.
Yeah, that's really awesome. So who are some of your sources of inspiration? Who are the scientists you look up to?
So the people that got me into this kind of thing, I remember watching Sesame Street as a kid and seeing astronauts on there. I remember Mr. Wizard, and then my parents, we were always outside as a family, camping, going up in the mountains in Albuquerque where I grew up, and just sort of turning over rocks. Like, it's that literal sort of discovery thing. Like, let's ask questions, and summer camps and dissecting things and just always trying to figure out why things work. And I think a key part of this was I was a Lego maniac, taking apart, build the thing on the box, and then let's see what else we can make with all these pieces. So it's just sort of this tinkering, wondering, curious attitude. As I've gotten older, you come to know these guys like Carl Sagan, my personal favorite, Richard Feynman, these guys who combine this sort of creative poetry with understanding the world around you, that it's not just dry facts and numbers, that there's this great beauty and enjoyment that can be found by figuring out how stuff works.
Yeah, yeah. It makes me think of Feynman's, the beauty of a flower thing, right? Where he's saying,
Yeah, the ode to a flower.
yeah, yeah, right. As a scientist, you see a flower and you see it for its beauty, but you also see it for the scientific principles that allow you to think more deeply about how it actually comes to be.
Yeah, I mean, stuff like that can get you in trouble. Once in high school, a girl I was dating back then, we looked up at the sky one night, and she said, "Oh, that's my favorite star up there." And then, me being the jerk that I am, I was like, "Actually, that's Venus," and that didn't work out very well. But otherwise, I would recommend it.
That's awesome. That's really good. So you're very interdisciplinary, sort of by nature, on your blog, right? It's really clear, and you have this awesome link. So everyone, when you're watching this hangout in retrospect, go to It's Okay to Be Smart and click on Science Links at the top of the page. That's an amazing list of awesome content. So I wanted to ask you, what are your go-to favorite sources for consistently epic science content?
So my favorites right now, I mean, there's a lot of amazing science writers, and just sort of like, writer doesn't even capture everybody today. It's just this big online streaming whatever that we're all doing right now. The National Geographic Phenomena blog. This is Carl Zimmer, Ed Yong, Brian Switek, Virginia. This is just a fantastic group of people, some of the most talented. Wired, where I'm lucky enough to work. They publish great work here and also have their own sort of set of science bloggers. I really recommend checking them out. Twitter feeds, these are hugely important. I mean, these are people who we all wonder, how do they have time to go through all of this every day? Even I wonder that. People say, how do you have time to go through it every day? Twitter is an amazing resource for things like this. It's like those old ticker tapes that used to come into the newsroom back in the day. That's kind of how I treat it. You can dip into this tidal wave stream and sort of pick out little bits of interestingness. And if people can look through my Twitter lists, I've got some there that are for science that I think are full of really great resources. So J to the Izzo is my Twitter. My lists are all public. Check that out. That's a Jay-Z reference. There are too many great science writers out there to name individually, but that's what's so great about the way that we're putting this information out there today, is that everyone has access. I would just direct people to my links page. There are so many on there. There's so many tools and lists and ways to discover, whether it's on Facebook or Google+, Tumblr, Twitter. These are all just amazing. Everybody has a voice now, and you'd be amazed at what you just pick out of the stream that can really help you out.
Yeah, it is really awesome. So I just posted on the event page your It's Okay to Be Smart links, and then I also posted your Twitter list for brain food. It's a great list.
Yes.
Yes. So Twitter lists. Congratulations on 10,000 Twitter followers, by the way.
Where's my trophy, guys?
next time we'll grab one.
I'm pretty sure they're all real people too. So.
Which is awesome. That's a feat in itself. So next we have a special guest from the Science on Google Plus community here, Benjamin Beaulieu, and who has a question for you, Joe. So Ben asked a question actually on the event page, and we invited him to join the Hangout. So continue doing this, because this is the very beginning of our Hangouts on Google Plus. But without further ado, Ben.
Absolutely. So you were just mentioning the ability for everyone to access science information everywhere, and it's ubiquitous. It is literally everywhere. But how does someone without a science background wade through some of the conflicting information that comes across? So you look at the article that says, looking at dietary stuff, coffee causes cancer, and then literally a week later, coffee cures cancer. And then you look at science news articles. So that's question one. How do you wade through that? And question two, what are some red flags when you're reading a science-related news article that lets you know that what you're reading may not be the whole picture?
So wading through what's real and what's fake, I mean, this is sort of the heart of the scientific enterprise, right? Of what it means to these words like being a skeptic or being a scientist. It's being able to weigh what's real from what's maybe not real. It's something we all struggle with. Even people who do this professionally have to sit there and go, what is this really what I think it is? And that's a skill that takes people years to learn. So one way to do it is to get a PhD. That's probably the biggest part of getting something like a PhD, is learning how to weigh these things for what the value is. my biggest piece of advice is to find trusted people that you can follow. And this is where these things like these Twitter lists can come in handy. There are people who are incredibly skilled out there at weighing the good from the bad, and it shouldn't fall upon everybody out there to have to make that decision for themselves all the time. So there are trusted journalists, trusted writers that nobody gets it right every time, but you can trust people like Carl Zimmer writing at the New York Times that most of the time he's going to get things right. That's been kind of, in recent years, we all know the downfall of traditional science writing. You can't really open your newspaper and find it in there anymore. And because the world is kind of flat online, it lets people deliver a lot of misinformation out there on whatever.com. So tips for finding the BS. Any disease or study that says cancer is caused by X or X cures cancer, you can throw that away right off the bat. It's important to remember things like diseases like cancer aren't even one disease. These are hundreds, and even an individual cancer could have dozens of diseases inside of it. So nothing is ever firm, hard and fast like that. And very few diseases, if you ever see, is caused by X gene. There's only a handful of diseases that are caused by single genes. We have 20,000 of these things working together in our body. These are combinations that you have to get used to. Never read a website that gives you a question as a headline. That's if they can't answer the question themselves before even getting to the article, then I would throw those out right away too. It's really just about finding trusted voices and trusted sources. Science is a process of self-correction, and no article, no finding, no paper ever defines a fact like people are used to thinking about facts. And this is just one of those core values of science that we have to get across a little bit better, that everything is a process and nothing should be declared definitive. Anytime we put our toe in to write an article about science, a paper that comes out, a finding, a new discovery, is just a step in the midpoint. There's a future and there's a past, and we're only doing our best at any time.
Okay, thank you.
That's a good answer.
Yeah.
So you can listen to me most of the time, I guess, but I guess I'll admit that.
So now we have some other questions actually that were posted on the event page.
Yeah. So.
So I'll go next.
Go for it.
Yes. So the first question I just thought of is, how did you come up with the name It's Okay to Be Smart?
So I'd love to have like a beautiful, inspiring story about this, but it's sort of like when you sign up for any Twitter or anything like that, you go, what do I call what's my screen name going to be? But it came back to this.
J to the ISO.
It's worked out well.
Yeah, I think so.
It came back to this idea that there are people out there in science classes drooling on their desk, with a PE coach trying to teach them evolution, the intricacies of chemistry or something, and getting the wrong impression of what science is about, and that it's not fun. And I hate to see people having this experience. And then the people who are interested, there's a lot of social pressures that are holding them down from expressing themselves. And sure, we've got shows like The Big Bang Theory. We've got enormous conventions like Comic-Con sort of embracing what it means to be a geek, what it means to be smart today. But I think there's a lot of people who are still kind of afraid to connect with that side. They feel they have to be into science or something else. And I just want to show people that this can be part of any person's life, a scientist, a chef, a banker. Doesn't matter what you do for a living, that this is something that you can involve, you can make a part of you. So it's just this sort of reminder that, it is okay to be into this and also into what you're into.
Mm-hmm. Thanks. And then the next question we have is from Akshay, and he asks, why are viruses not defined as living things?
Well, that's a setup question. Viruses, this whole question of what life is, I happen to believe is the wrong question. I think that it's more of a question for maybe a poet, philosophers. This is really a philosophy question, not so much a science question. Viruses are breaking all the rules all the time. I mean, okay, so biology is the study of living things, right? That's what we do as biologists. If we were to take this word apart, this is the ology of studying living things. So are virologists not biologists? You know, are they not studying a part of life? So we can sit here and try to define it and say this is X, it's a self-replicating system, it has information inside of it, but there will always be exceptions to these rules. So I say that finding a definition of life is the wrong question. Instead, let's just study the things that we interact with as part of our biology. Biology's life is one of those things that's it's like porn. You know it when you see it, but you can't really define it very well. So I mean, it's viruses.
Are you just quoting is that a Tipper Gore quote?
That might be a Tipper from the parental advisory days. So viruses, are famously not called alive because they can't self-replicate. They don't make their own machinery for replicating their genomes and their proteins. They take advantage of their host. They rely on these other quote-unquote living things. Well, they can't survive in isolation. But could you survive in isolation? I mean, does any species of anything not rely on hundreds or thousands of other species? I mean, we have thousands of species inside of us right now that are helping to keep us alive. So does that mean we're not alive? I don't know. These are definitely the wrong questions. And viruses very recently are starting to sort of redefine our assumptions with the finding of Pandora viruses that are nearly the size of bacteria, thousands of genes, half as many as an E. coli. Everywhere we look, we're finding more and more complex, quote-unquote, life, maybe not life. It sort of makes sense in an evolutionary perspective that you have what we would call maybe the basic unit of life, a bacterium or a cell, and you'd have viruses. Well, there's going to be a continuum of things in between those two, and just because we haven't found them yet doesn't mean that they're not out there. So, yeah, hopefully we can maybe throw away that question of trying to define this and leave that to the pure poets and just sort of getting on with describing how cool it all is instead.
So you mean it's complicated then?
Yes, the universe is complicated, and
good to know.
Don't have. It's amazing. Science doesn't have firm answers, and that frustrates people, but it excites me.
Yeah, right. That just means you get to discover more solutions in the future.
Exactly.
So on that sort of, how people think that science is sort of the be-all, end-all, and it's giving us the answers, right? I think that's what a lot of people think. So we have another question from Akshay, actually, who asks, what do you picture the future of education to look like, and what would you suggest teachers and lecturers do when it comes to innovate in their ways of teaching? How might they innovate and sort of address a lot of these things that we were just talking about?
Things that I'll leave out here are sort of these sort of educational policy things where it comes with curriculum and dealing with teachers and how things are decided. I'm not going to comment on that stuff, but from a motivation standpoint, how do we harness new technologies? How do we connect with people better? It's going to be this online part of this is that this environment is coming into classrooms more and more, but I still think it's sort of a supplement. I think it's an extra. It's let's watch a video and then get into the traditional lesson or something like that. We'll see if these MOOCs, these online courses, are going to be good solutions for people, especially for maybe some underserved communities around the world who don't have built-up infrastructure, built-up universities and centuries of teaching experience. I think YouTube is going to be a big part of it. YouTube does publish this EDU channel that's piped into schools around the world. These are vetted channels in a number of subjects, from chemistry to math to physics to biology, that give teachers a way to deliver things a little more exciting, kind of wake the students up before class and put the Higgs boson or something into perspective before they get into the nitty-gritty numbers about it and lose half the guys. But that's going to be a huge part of it. But all these things come back to connecting to the culture of your students. There's a great education researcher named Christopher Emdin who deals with minority and inner city urban youth and trying to connect science to them. He has this initiative called Hip Hop Education, and his philosophy sort of revolves around we're gonna we're going to recognize your culture as young people, where you live and what you deal with and what you're into. We're going to use that to guide our lessons, to bring it into our lessons, to say it's not just us delivering what we want to you. We're going to make this a two-way conversation. So it's respecting their culture. It's understanding that young people are into GIFs and cat pictures and things like this, and that's not the best way to deliver a calculus lesson. But if you can sort of come into their territory, I think you're going to communicate a lot better with young people.
I like that.
Yeah.
So we actually have another question here from the crowd, from Robert Jacobson, and he's asking you a philosophical type of question too. He's asking you, Joe, how did you come to be who you are? A lot of people love science but don't work at Wired. Were you just really lucky? Are you super driven?
Well, man, autobiographies are famously inaccurate, so I don't know who can look at their own history. I've always been into two things: asking questions, and then, no matter what other people think, having to tell them the answers to these questions. Whether that's teaching in a classroom or being the annoying guy at a party who just has to tell you, "Oh my God, did you see this thing that came out this week?" My wife famously makes fun of me for always saying, "Oh, did you see this article?" It's like always about this article that I read. So I'm a sharer. I'm a teacher, and that just drives me. I'm addicted to it. When you see that sort of spark in somebody's eye when they understand something or see something for the first time, that's better than any drug. For any teacher will tell you that. So getting to do that on this platform where I can talk to thousands of people, like I said, it's not a job. But how do you get here? Maybe the real question that I sense in a lot of these is, how can I also do that? And maybe a little bit of it's luck. It's putting yourself out there. It's meeting other people who are into what you're into, being involved in these communities that help and support each other, like these online science communities. Pages like these Google Plus communities are huge resources for this, to meet people that you'd never get to interact with otherwise. We have a literal global network of people who are all trying to do the same thing, so that's a great start. Not everybody does get to work at Wired, and in a few weeks I'll be back to real life myself. It's all about being prepared and working when you don't think anyone is listening, and just trying to do the best job that you can all the time. And usually if you keep a positive attitude and don't get cynical about this and have this attitude that you just want to share and teach, I find that pays off every time. It's about keeping this up and more yeses than nos.
So related, how do you keep from being cynical? Cynicism is easy to fall into when you see people who are indifferent or just don't care. So how do you keep your passion levels up when it seems like you're talking to dead air?
Oh, right, when you don't think anyone's reading. Well, don't ever depend on your comment sections for self-esteem boosters, because that'll never work.
Unless I'm going through your archives.
First and foremost, I think that a person who writes and who teaches does this because they have to do it. They get a sense of pleasure out of the action. This isn't most people that write or make videos who are creating this content wouldn't call it a job. It doesn't mean it's not hard, but the motivation at first has to come from within, and that's ultimately what drives you. Because I get there, I have 8,500 something posts on my blog at this point.
Wow.
And there are days when I wake up and I'm like, I don't want to do this. So I have a secret that I have this motivation file that I keep, where people send me messages, just little notes of, hey, this post helped remind me why I like science, because none of my friends are into it, and I never get to, my teacher's no good in biology, and if I didn't have this page, then I would never get to experience this. So I have this folder full of messages, and any time that I'm feeling down, then I can look at this and say, you know what, this does make a difference. And for some people, that might be one person that you made a difference with. Staple that to your bulletin board, stick it to your mirror, and just look at that, because this isn't the job of any one person. This isn't, one Bill Nye or something is not going to change the world. this is going to take kind of an army of people online that are sharing in the work. So staying motivated is tough, but you have to trust that you're doing it for yourself first, and that every little bit makes a difference.
Mm-hmm. Yeah, I like that. So let's see. We only have about 4 more minutes left. So let's do one more audience question. Wow, these 30-minute hangouts. This is short. It's really short. So I like this interesting question from Im Dominguez, who came in from the Questions app that we're sort of beta testing for Google here. I'd like to get the panel's perspective on science and existentialism, but really basically is asking, how do you explore using science to say what something is rather than saying what something does in a particular context? I think he's asking, how do you, and Im Dominguez, correct me sort of if you're, if I'm interpreting this in a wrong way, but it seems like you're asking maybe not just looking at, so I think that you asked this in the context of the virus question that came up. So exploring how we define something versus understanding more about it. Maybe just exploring it for the sake of knowledge rather than having to necessarily try to find answers. I don't know if that's not even a question.
Well, this has been a problem. This has been a problem in with the very idea of a species, right? So we have to name things. We have to classify them. We have to describe how they're related to other things. But then we end up with this system where, you know, individual species don't really give you a picture of evolution because there is no. This is a steady stream. There's no finite points along this pathway. So. It is sort of a limitation of having to describe things. You can't, I mean, how do you look at a rainbow and pick out a single color? I mean, sure, there's like little bars, but this is really sort of a spectrum. So we choose to describe it with Roy G. Biv because that's the best we can do at a certain point. Or you can dig down and find some wavelengths in there, but there's always 2 numbers between every other number, and maybe this is kind of a weakness of our approach to describing things.
Well, speaking of how you describe things, you are kind of well known for GIFs, describing science utilizing GIFs. So I want to talk to you a little bit in the last couple minutes about science GIFs. Where do you find them? Do you make them? Just tell me about GIFs, Joe.
Oh, GIFs are amazing, and I am on Team GIF, not Team GIF, no matter what the originator of the.
That's because you like to be right.
Yes. GIF is a peanut butter and not a graphics format. So, American audiences will get that one. So GIFs are amazing. This is videos are great. There's a lot of visual and still photography is great. Those illustrations are great, but there's something about a picture that you don't have to do anything to. You don't have to press play. It's not going to play noise. It's not a Vine. It's not Instagram. It's just sitting there moving. I mean, it's amazing that it's effortless engagement with the science, and it loops, and you can do all these cool things with them and slow them down and take pictures apart. So how do I make them? You can find them a lot of different places. You can go to my blog, you can search the GIF tag. You actually go to tumblr.com/tagged GIF. There's all great kinds of tools. It's probably
We'll post a link to that.
Yeah, we'll post a link to that later. They're not tough to make if you got Photoshop and ways to get your hands on YouTube videos. It's a little technical to go into it, but I just find them amazing, like the way that you can capture motion and tell a story with it that you just couldn't do with your words and you couldn't do with a still photo. It's like this awesome animation hybrid video effortless information device. I just love them.
Yeah, I am a huge fan. We've been sharing some of them as the Science on Google Plus page leading up to this hangout, and they all have actually come from It's Okay to Be Smart from Joe's blog. So we're really at the end of this hangout. I want to thank everyone for coming with us. Thank you so much, Joe, for your time, and for all of the people who have RSVP'd and contributed with questions and ideas. Science on Google Plus is almost to 100,000 people, and our goal is to really bring science to life. So whether it's through these, Science on Google Plus Hangout conversations, we're really expanding. This is only our second one. There will be many more. We've started to kind of collaborate with some of the other large science communities on Google Plus. Think, space or mathematics, which it's a testament to Google Plus that one of the 50 largest communities on the entire platform is mathematics with 70,000 people. But we'll be doing poster presentations, virtual journal clubs, think lab tours, literally, so periodic videos, but in real life. We'll be bringing more science stars and unknown scientists who are doing amazing work to you, and starting conversations and bringing science right into your life, and then connecting you through science with people who have kind of a mutual interest. So we encourage you to continue the conversation on this event page. Make a circle of the people who you've interacted with during this event, and keep it going. And let us know what you think of this event, and let us know who you would like to hang out with in the future. So I guess with that, we will bid you adieu. And thanks everyone for coming. Thank you so much, Joe.
Thanks, Joe.
Thanks, Joe.
Thank you, guys.
All right, we're ending broadcast.